Functions. First of all, when given an ordered pair x and y, in this case the x is the independent variable and the y is the dependent variable because the value of y depends on whatever the x value you substituted in for and solved. A relation is simply a set of ordered pairs. A function is a specific relation in which each x coordinate is matched with exactly one y coordinate. So let's look at some relations and see if they are functions or not. Okay, so we look at the ordered pair, the relation A, and we look at the x terms. 1, -3, 4, 6. Every x is paired with exactly one y, so we would say this is a function. Okay, let's look at number 2. So we have the x value of 0, -2, 1, 4. Oh no, we have the x value -2 that is paired with different values of y, so this is not a function. Every x is not paired with exactly one value of y. Alright, so let's look at C. We look at our x values. -2, 4, 3. Yes, this is a function. Okay, every x is paired with exactly one value of y. So 1 is mapped to 4, 2 to 6, 3 to 6. So yes, this is a function because every x is mapped with exactly one value of y. Alright, let's look at E. X of 4 is mapped to 0, and then 2 is mapped to 0, and 2 is also mapped to 3. This fails to be a function. If I wrote these as ordered pair, 4 was mapped with 0, 2 was mapped with 0, and 2 was mapped with 3, we can see that these x values, the x value 2 is mapped with more than one value of y, so this is not a function. Next, we're going to look at domain and range. So in a relation, when you have an ordered pair x and y, the set of all the x values is the domain, and the set of all the y values is the range. And take note that when you graph these things, and when you name them, you want to name the domain from the left to the right, and the domain from the bottommost point to the topmost point for the range. Okay, so but first of all, we're going to start off with the most basic relations. And so your domain is all your x values. So it would be -4, -1, 1, and 3. So -4, -1, 1, and 3. The range is all your y values. -2, 0, +2, 5. So -2, 0, +2, and 5. Okay, we're going to do the same thing. Do the domain values, and then this is your range values, so we just list them. The domain is going to be 4, 5, 6, and 2. Your range is going to be 7, 8, and 9. Very basic. Okay. Let's look at domain and range when given a table. The domain values are the -2, 0, and +2. The range is going to be just the set 4. When there's more of one that's repeated, you only list it one time. Okay, so let's look at A down here. The domain is the x value, so if I arrowed up, this is x value of a -2. This is the x value of a 1. This is the x value of a 3. Alright, so the range is the y values. So we have a value, okay, let's start at the bottom. We have a value of -1 for our y. We have a value, if we arrow over to the y-axis, it's easier to see, so then we have a 3. And then we also have a 4. Okay, so we name domain and range like that. On part B, I'm going to name it a little bit different. I'm going to list them as ordered pairs. This is the ordered pair. -2, +1. This is the ordered pair 3, -1. This is the ordered pair 1, 3, and this one is 2, 3. So I could also list my ordered pairs and then go back and say the domain and list all the x values. So -2, 3, 1, and 2. And sometimes it's nice if you put these in order according to the number line, but it's not incorrect if you don't. It just may be more formal. The range is a 1, a 3, a 3. I won't repeat the 3's. 1, 3, and a -1. Okay, we'll make sure that we have all of those. Alright, the domain is so when we're looking at the domain, it's the x values. The leftmost value on this graph is an arrow to the left, which would mean -infinity. The rightmost point on this is an arrow to the right, which is +infinity. The range would be the bottommost point on this graph, which is here, which is a y value of 1. And the topmost are both the same and their arrows pointing up, so they're infinities. Okay, let's look at D. The leftmost point on the x value is here, which is a 1, bracket 1. The rightmost point is here on the x value is a 3. The bottommost value on the y-axis is a 1. This is for our range. Bottom. Topmost is a 3. So for a circle, we see our domain and range are going to be the same. Alright, we move on to E. The domain is the leftmost x value is an arrow pointing to the left. The rightmost x value is an arrow pointing to the right. The range is talking about our y values. It's the bottom most are arrows to the topmost, which is a 4 bracket. Okay, on our last one we have the domain is going to be the leftmost, which actually these pair up to be the same. It's still -infinity, but it goes to -1, and then we have a gap right here. So when there's a gap, we're going to put a union, and then it picks back up at a 1, and then the rightmost values are to infinities. So that's the leftmost to the rightmost, and then we have our range, which is the bottommost portion of the graphs here, which is arrows pointing down, and then the topmost points are arrows pointing up, so we have -infinity to +infinity. Okay, vertical line test says every vertical line intersects the graph of a relation and no more than 1 point. It's a function. So you can use the vertical line test on the relations graphed above and determine if it's a function. So let's go up to the top. I'm going to draw a vertical line. Okay, if I draw a vertical line, it can only touch my graph at 1 point. So it doesn't matter where I draw a single vertical line, it's only going to touch it at 1 point. So this is, yes, this is a function. Okay, let's look at the next one. If I draw a vertical line here, it touches it at 2 points. So I'm going to say, no, this is not a function. Okay, let's look at this one. Vertical line, it's only going to touch it in one place. So yes, this is a function. And F, we say it doesn't matter if it fails 1 point, this is not a function. Anywhere that I put this over here, this is not a function. I think we had a few more. Let me go back a page where we can also look at these. So this one is not a function because it touches 2 points, but this one is, because it doesn't matter where I draw it, it's only going to touch 1 point at that time. So this one be, yes, this is a function.